Okay, so now that we learned about the electronic configuration like S, P, D, F, now let's try and look into a very interesting and very simple concept called the quantum numbers. Now, what's the purpose of a quantum number? Now, let's say you are a student in a class, okay, like you are in grade 7 and say section B, okay, so, and your name is Ted, okay, so each student in any class in your school will have a name, right, and that particular student is in a grade, and say there are different sections in the grade, and each of them have a roll number, right? So name is Ted, grade 7, section B, and say roll number 22. Okay. Now, in your school, there can be many students with the name Ted. Okay. Also, there can be many students studying in grade 7. Similarly, there will be many students studying in grade B, right? So you have all these different grades, grade 1 through 10, whatever, and then each of them have like different sections, and all those sections in which there are students, all the sections that are named B will have a huge number of students, right? So there will be many students will have grade B, section B. Now, also, there will be many students who will have the same roll number, like every grade, every section will have certain sets of roll numbers, like going from 1 through whatever. So there will be many students in the school who will have roll number 22. But how will you identify a student uniquely in a school? A set of these 4 will try and give you a unique set of identifiers for a particular student. What that means is no other student in your school will have all these 4 things same. It has to differ. You cannot have another Ted in grade 7 in section B with the same roll number. It cannot happen. Even if these 3 are same, that person will have a different roll number. Now, there can be another Ted in grade 8, say, who is in section B and have a roll number. But all these 4 together is a unique set of identifiers for a particular student in a school. A similar thing is happening for any atom, for any electron in an atom. Say you have a particular electron in an atom. We will come up with a set of 4 numbers called the quantum numbers, through which we'll be able to, there are 4, right? There are 4 quantum numbers. Using these 4 quantum numbers, we'll be able to uniquely identify an electron in an atom, like you were able to uniquely identify a student in a school, okay? So this concept is called the concept of quantum numbers. Now, please don't be scared with the name quantum. Yeah, it has its roots in quantum physics, but in here the concept is extremely simple. Any middle school student will be able to understand the concept of quantum numbers. Okay, so without further ado, let's start with the first quantum number, which is the principal quantum number. Okay, so the first quantum number is the principal quantum number. It is represented by the letter n. Now, the concept is extremely simple. The principal quantum number is the nth orbit in which that electron goes. Let's try and understand this with an example. Let's take the example of sodium. Okay. You have 11, so you have K, L, M, okay? If I tell you, okay, let's also write down the SPDF. Now, if I ask you the principal quantum number of this electron, so there is an electron associated with it, right? So represented by this box. If I ask you what is the principal quantum number of this electron of sodium, the principal quantum number will be 3 because it is from the orbit 3 or from the period number. So this basically gives you the period number, right? The n. So this is basically the principal quantum number. Okay, just this the number of shells. So if you represent this, so say you have the nucleus in here. Now you have shell 1 or the shell K in here. There will be another shell with the second n equal to 2, the third and the fourth, and so on. Now you see, when you are increasing the n, you are increasing the size, right? So basically n, which is the principal quantum number, which is just the nth shell of that electron, right? So in here, if you say, okay, what is the principal quantum number of the electron which is in shell L? It is 2, right? And if you see here, so these are the 2, so 8, 2 are going here and 6 are going here. So in here, the principal quantum number becomes 2. In here, the principal quantum number becomes 1. In here, the principal quantum number becomes 3. So this is just the concept of the principal quantum number, right? And this is how it relates. So n relates to size. Like as n increases, the size increases. When the size increases, the distance from the nucleus also increases, right? So when you're moving out, you're moving away from the nucleus. So if there is a principal quantum number that basically represents the size, that it gives you the idea about the size, which is actually the nth orbit, and which gives you an idea of the size, okay? So this is extremely simple concept. You can find the principal quantum number for anything, okay?